Hello, and thank you for being here. Today's talk is going to be about the software development cycle and then how that relates to the Bowman Avenue Dam. There are basic models for software development cycle. There's a whole bunch of different types of models and methodologies, but there's a few that are pretty standard that we're going to go over, and we'll see how that integrates into the dam. So we're going to be talking about those basic models. We're going to be talking about methodology that we can use for the dam, kind of collaborating different parts of basic foundational methodologies, and talk about just the different phases of the software development lifecycle, different security principles that we can bring in to make sure that the software development lifecycle is secure all the way through from the beginning to the end, and from when we use that software in our systems and our operations. We're also going to talk about the maturity model and then how that relates to the software development cycle and just our overall security framework. So there are several different basic models and methodologies for software development cycle. One that's been very widely used is called the waterfall method, and it breaks down the different phases so that you're only doing one phase at a time and that you only move on to the next phase when that previous phase has been completed. The reason they call it the waterfalls because it has to be done, then it'll go down to the next level, go down to the next level, kind of looks like that. You can draw it out differently, that's just the way they've done it, so that it has to go from one stage to the next, and it goes down like that. Another method is called agile. Agile methodology is used in different kinds of project management also, but for software development lifecycle purposes, what it does is it's very reactive. It doesn't go from phase to phase to phase to phase in that very structured and spaced out timed manner. It reacts to what the customer wants and what the customer demands, and there's constant feedback back and forth. Okay, we're going to do this, we're going to do this, we're going to do this so it can do this, and they talk to the customer about it back and forth, and they develop it like that, very agile. Another method is called the rapid application development. This is done similarly to the waterfall. It's just more rapid paced, as the name would say. They do a step, they have it tested, they fix it, they do a step again, they have it tested, they do it, they have a step. And it's very boom, 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 boom. They try to get a step done, they get it tested instead of going through the whole process and then testing it later. So it's very back and forth and it's rapid, so they try to get it done very quickly and try to get it done in that kind of manner. A joint application development method is kind of similar. It follows the same kind of structure, except they just include different teams all working together from different areas of the software development or the customer side or whatever to try and collaborate to get that rapid development moving and done more effectively. Extreme programming, kind of how it sounds, it's kind of a fire drill extreme kind of method where like two programmers will sit next to each other and they'll just pound out code until they're done. It could be take up the whole day, it could be that week, but like one's writing, one's looking it over, they're both giving input, and then they just knock it out as fast as possible before they move on to the next piece of code that they want to do. This is done so that they can get it done as quickly as possible, and that second person is supposed to be there to kind of proofread as they go, so instead of writing it and then sending it in to have it looked at and tested and all that, it's done at the same time. Obviously there's pros and cons to it. For quick fixes that can be good, and for just smaller projects that can be good. For longer term things, you can't just knock it out that fast, especially if there's a bunch of different teams that could be involved with it. There's also another way, and this just goes to show that different organizations can modify different methodologies in different ways. The NSA developed a method called the NSA way. It's developed by Sula Fortuna and Bob Moore. Basically, it's kind of like waterfall, except instead of it picturing like a waterfall, they have different gates. And in order to get through the different gates that will enter into the next phase, it has to meet certain metrics, certain requirements. There's coaches involved that are at each different step that kind of bring it through that process. This was done so that programmers aren't just doing it themselves, so that there isn't just one head of knowledge of a certain area of the programming or for development of a certain field within the NSA. So they can have a structured process that'll have multiple people involved, and it'll have a structure throughout the entire organization in case somebody else needs to step in to help, or people are moving or people leave, that they're not just left with nothing and nobody, that they're left with a structured process that have different people in place to watch that process. And so like they modified waterfall in different ways, the Bowman Dam can also modify it for our own use. So the way the Bowman Dam would use these methods is it would be closer to the waterfall, so that it has that kind of structured plan, especially since we're government, especially since we have secure facilities that deal with things like the dam itself. We need to have these very specific and structured processes in place. Other methods like agile and extreme programming can be good and fine for us in certain circumstances, certain software fixes that need to be done, or something crashes, we need to get something done, like things like that. But the overall structure would be close to the waterfall and kind of closer to the NSA method, the NSA way, where we start with one process, go to the next one, go to the next one, go to the next one to make sure everything is done as completely as it's supposed to be and as securely as it's supposed to be. Because we're also trying to bring in a lot of different security, more than even the average organization would, because we are government, because we handle these kinds of systems. That's probably why the NSA way did kind of a similar thing. They need to go through a very structured thing. So the different phases of the software development lifecycle, depending on where you look, or what book, or what website you look up, they're going to be a little bit different. Some are going to go super in depth, some are going to go super high level, they're going to call things differently, but they follow the same basic structure. The first general phase is just the planning phase. You go through your plan, what is needed, what do they want, what does the customer want, or what do you want, and they try to figure out how they're going to accomplish that. Just the very basic planning phase. Next after that, is to develop requirements. So after they plan out what they want, how they're going to do it, they have to plan out these specific requirements for what needs to be accomplished and how they're going to do it. This just gets a little bit more, like the planning is very high level, the develop requirements gets a little more technical, try to develop the specifics of what they want instead of just the general overall idea of what is wanted. After that, go to the actual coding phase. The programmers will sit down, bust out code, type it all out. I mean, they'll do their own internal checks to make sure that their code is working and doesn't have bad loops or anything like that in it. And they'll go through that process. That's the very in the weeds, putting the numbers and letters in there, trying to get it done. After that, testing it. Now, this is different than just the programmers testing it themselves. This is putting it possibly into a mock environment that would mimic what the actual dam systems would be, and then testing it that way. See what bugs pop up. See if somebody tries to run a program over here while someone's running a program over here, is it going to interfere with each other? Is it going to cause problems? Things like that. It's also testing security-wise to see if there's any malware or anything that could crash the system, cause damage to the system, leave weaknesses in the system, things like that. Next is actual integration. It'll be actually put out into the systems. It might not be all the systems right away. We can put it onto some systems, just depending on what is needed. And then that'll kind of also be a little bit of a testing phase too. Now that it's not in a mock environment, it's in a real environment. They're going to test it and they're actually going to try and use it and see what's going to happen. Then lastly is just the sign off of it. Once it's all done, so it's signed off on, that it's completed, and the software development cycle is done. Very good. There's always going to be more testing and fixing, but as far as that singular cycle goes, it is done. For different security principles, we already talked about different security measures that need to be in place for like supply chain, and that's going to fall in place here also. If we are going to be buying software from somewhere else, it needs to follow that security structure. The vendor needs to be vetted. The software itself needs to be vetted. We need to check into how they vet things. All these things. We need to test it in our environment like we do in our own internal cycle to make sure there's no malware, nothing's going to hurt the system. All these things are going to be put in place before it's actually integrated, before it's signed off on. The maturity model kind of follows through with all these things. It follows through how you're going to mature the model, how you're going to mature how it's used. So how it starts is the initial phase, where it's used and it's not used maybe as well as it should be or like it should be, but it's out there and it's being used. After that, it goes into the managed phase. The managers are trying to take more control of it, trying to make it so that they're able to contain and try to structure what's happening with the software or the development of how they're using it. Next is defined. Managers and the users of it will get more technical in how they're using it, start following the rules to the letter a lot more. It's going to be a lot more structured. It just keeps building up to being more and more refined. Because after that, it's predictable. So instead of some people are using it, some people aren't, it's working over here, it's not working over here, it's going to be more predictable. There's going to be more of a baseline. It's going to be working, except in these instances, and it's going to be predictable. After that is optimization, where you're moving from that it's predictable how it's going to work to now that it's working, we're going to make it work better. We're going to make it more efficient. We're going to figure out ways that we can use it better. And that's the maturity method. And you can use that all through, not just after it's implemented, but during the cycle itself. If you're planning, you're coding, you're doing these things, during the testing phase especially, you're testing it out, you can kind of guess, it gets more predictable, and then you're trying to optimize to figure out how to do those final fixes before it's implemented. So that is the basics of software development lifecycle and how we can use it here at the Bowman Dam. We went through the basic methodologies, what methods we can use here. We went through the different phases of the actual lifecycle itself, security measures, and then the maturity model. Thank you very much for being here, and have a great day.